So coming to the final experiment of the stacked 2D structures, it is the Optimetrics on a patch antenna. So a patch antenna file will be given to us which is operating at 1.8 gigahertz, and you can see the structure over here. Everything is set up properly with analysis and with all the boundaries, with all the boundaries and excitations and everything. It's a probe fed patch antenna. So all you have to do is run some parametric analysis or optimetrics on this patch antenna and make sure that the nominal value which is selected here is the perfect one, or try to optimize the antenna further. And to do that it's just a 1-2 step process, and this experiment is the most easiest one amongst all you need to do is run some optimetrics on this antenna and simulate and obtain the right results. So before doing that, you can just validate this original file and run this, which I have already done by just clicking on analyze all. You can run this, and then if you just plot the S parameter in the usual way, modal solution data report and rectangular plot, so you can obtain this graph. So you can see that this is operating at around 1.79 gigahertz, which is very close to 1.8, and the return loss is minus 31.90 dB. So you can see that, and you can also plot the radiation pattern by going into results, far fields report, and radiation pattern and gain and dB. So which I've plotted that already, and you can see this is the radiation pattern for 50 cut and 590 cut. So these are the two things that you need to be optimizing over here, and the two variables that are defined over here are feed position and patch length, as you can see. So the antenna dimension, which is the patch length, is inversely proportional to the frequency. So as the frequency increases, the patch length should decrease. So smaller the antenna, the operating frequency will be larger. So that's the relation over here. And feed position also related in quite similar way. So yeah, you need to select one of these variables and or both the variables, however the invigilator or the examiner asks you to do. You can select one of these variables and run your optimizations, and to do that it's a very one-step procedure. So you just have to right click on Optimetrics and go to add and then parametric. So over here you can find this option called add. So the feed position is already selected. Let me select that, and you can be at linear step or linear count, however you are comfortable. I am comfortable with linear count, so I'll just run from 9 to 12. So you can see the nominal value is 10.45. So around this range I'll be running my parametric analysis for 9 to 12 with the steps with 5 values. So I can just press add over here, then press OK, and then press OK again. So this will get added in your Optimetrics. So you can see two of them have got added because I had already added and run the simulation initially. So I should be able to obtain the results as soon as I plot it. So after you add this, you just have to make sure that you validate the simulation and analyze all again. So once you run that, which I've already done just to save some time, again you just have to go to rectangular plot and plot this. So then you'll be obtaining these many plots. So yeah, you can see I have actually run parametric analysis for two values, which is both feed position and patch length. So it's depicting so many graphs, which are 10 graphs. But you don't have to do that, or you can do that depending on the what examiner asks. If you can just run on one value with 5 counts, then you'll get like 5 graphs, and you can see clearly this is the most optimum one, and it's 10.45 and 41.6 mm, which was already there. So to carry out more optimizations, you can keep running these simulations and check which one is better. And with these obtained values of feed values, feed position and patch length, what you can do is you can change the variables over here. So for example, I can make this 10 and plot the radiation pattern. So this radiation pattern is for the fixed values, which is 10.6 and 41.6, if I'm not wrong. Yeah, 10.45 and 41.6. So if you want to plot radiation pattern for the values that you obtain here, for example, if I want to plot for this, you can see it's 10.5 and 41.6. So I can just go over here and change this to 10.5 and keep this at 41.6. Then again run the simulation, Then I can obtain the radiation pattern for this particular uh, values. So you can just keep doing that, the optimetrics for this patch, and all you will have to be plotting is this one, this plot, which is for the existing file, the radiation pattern for the existing file, and then these 5 to 10 curves depending on how the examiner asks you to do these curves. And then yeah, you can change these values and plot the radiation pattern for the new ones. So it was a simple procedure. So the major thing you have to remember is just go to Optimetrics, add parametric, and again add. You just have to select one of these variables here, make it linear count, and make sure it's around this nominal value. So for example, it's 41.6, so I can run from say 35 to 50 in steps of 10 or 5, and then I'll add it, press OK, and if I just simulate it, validate and simulate it, then plot the S parameter the usual way, you will get this kind of a plot which will have the plots for all the values, and this one is the most nominal one. So this is all about this experiment. It's a very simple one, and this is about the last 2D stacked structure when the file is given to you. Thank you.